ああ入ってるよね。So, shall I start my presentation? Okay. Well, today I talk about cryptography and open hardware and free software. First of all, I like to express my thanks to organizer, and I'd like to say congratulations to have this great conference, Open Source Hong Kong. I've heard that this is the first open source conference in Hong Kong. That's very good. And it is my honor to be here, and it is my pleasure to present my talk about the free software and the open hardware. And this talk is basically the invitation to free software and open hardware. This one is my open hardware project named FST-01. And this is the logo of my project named Gnuk. And I have a question. And how many GPG users are there? No one? Very few. Or how many open SSH users are there? SSH. Yes, SSH, secure shell. Yes. So perhaps the encryption is not that popular, although the protecting privacy matters. But using the secure shell, it makes sense to encrypt a connection so that you don't lose your data, important data. Well, this is the contents. I explain about the needs for redesign of hardware. And I explain the software, two software. One is a GNU Privacy Guard. It is a free software to protect our own privacy. And Gnuk is a firmware, and the FST-01 is a reference hardware. Well, the major problem of crypto tools is how to handle your private key. Yeah, that's a very important issue. If you care about your privacy or security, you should care about your private key of your open SSH. Usually, you guys just put your private key onto your disk. It is not considered safe, usually. So, but putting your important data onto unsecure hardware, it doesn't increase your security at all. So free hardware design is requirement for us. And this explains the computing freedom. It's more than I can do that. Yes. Let me explain about a minute about GNU Privacy Guard. It is a tool to protect your privacy, and it is we have a specification named OpenPGP. It is RSC4880, and it specifies about digital signature, encryption, decryption, and authentications. And GnuPG supports both standards. This is IETF, another IETF standards. Yes. And this is a logo of GNU Privacy Guard. And it is not that popular, but we can use GnuPG to handle open SSH keys. And this is very convenient. And we also have a Emacs front end for GnuPG. And you just open the encrypted file. Then it automatically decrypts. And perhaps some of you has experience using Enigmail with Thunderbird. And Password is another tool. It is a password manager. Yes. And the next slide is explain the Gnuk token. Gnuk token is that actually I have some tokens. This is a prototype. This is also prototype. This one and this one is an engineering prototype. And this is a final product. Yes. And this one is available at Seedo Studio. And Gnuk token is USB cryptographic token with Gnuk. The open hardware and free software implementation, that's a Gnuk token. What's Gnuk? It names after GNU and Gnuk. The GNU project is the most famous free software project, which started exactly 30 years ago. And it's for computer users' freedom. And Gnuk is another famous one, at least in Japan and Germany. And which was my son's favorite 3 years ago. And it means everywhere with it, always. And I wish Gnuk will be your favorite too. Yes, Gnuk sounds Gnuk. And it is OpenPGP card. I implemented specification OpenPGP card version 2.0. And it is for STM32F103 architecture. It's an ARM variant. And it supports RSA 2048-bit keys. Yes, this is a specification of the controller. The manufacturer is ST Microelectronics. It is not US-based, so you can rely on perhaps somehow. and architecture is ARM, as I said, and it runs at 72 megahertz. So if we compare the usual 32-bit computer, such that this one, it's quite slow. But it supports USB full speed, and you see the RAM is quite limited. It's not megabyte, but kilobyte, 20 kilobyte. And the flash ROM, we have some flash ROM. It is also small, but enough for your private key. Yes, this is a specification, features of Gnuk. It conforms to OpenPGP card specifications, and it supports 3 keys to sign, decrypt, and authentication. And the speed is about 1.5 seconds to sign some documents or to decrypt some documents. And I think that it's enough. And it also has a firmware upgrade feature. And here is the limitations. I deliberately choose using normal controller, normal processor. It means that we have no RSA accelerator or any kind of crypto engine. if we have such a special hardware, then we have to care about backdoors. So it's not that fast, unfortunately. But I hacked quite intensively so that it matches our needs of the something like 1.5 seconds. Yes. And it relies on just a flash read protection. Yes. But here is a good point. It is free software. Everyone can inspect the code, or you can improve the implementations for new things, such that authentication, newer encryption algorithm, or new protocol enhancement. And this one is open hardware. Its name is Flying Stone Tiny 01. And we only have a few components. It's a minimum design. And this is a photo of engineering prototype. Yes, it's just a two-sided PCB. I only put our components one side so that manufacturing process is easier. Yes. Actually, I hand soldered. Yes. Yes. And this is a product version. And it is covered shrink wrap tube. It's a kind of joke. It's transparent. You can inspect it. The design is available as a free, and here is a license, CC BY or CC BY shared like. The differences of license came from the modules I used. Yes, and this is a very important point that. During this design, I only use free software environment. I never use proprietary environment. So this is another very important topics about open hardware. Suppose that suppose you need some proprietary environment for the design of open hardware. At least I don't think it is good, because people can download a design, but it is not, if it requires proprietary environment, it is not 100% free as from my point of view. So I use KiCad. It is free software. Yes, here is an example. This is a schematic design under the KiCad. And this is a board design. Yes, this is a front side, I think. Yes, here is a processor. Here is crystal, and regulator, and USB chip. Yeah, yes, and the back side. This is my company's logo. So all the restriction is that please don't use my logo if you copy my design to your product. It is free to manufacture by yourself. Please copy my design for your product. But please remove that logo. Yes. Yes, here is a brief explanation about the history. I hacked it was 2008, 5 years ago, something like the Arduino. And I hacked the RSA routing, and it takes 5 seconds for RSA 1024. So 5 seconds, it's too bad for me. Although we can use somehow. So in 2010, I changed the choice of the microcontroller to STM. Then I started coding. The first target board was Olimex. And I added other target board. And in 2010 or 11, I found a very good target board. And then I designed PCB 2 years ago, and I asked manufacturing to see the studio to have a real product. And I continue my development this year too. And actually this year I have my own real-time OS. And here is the availability of the Git repository and the products. Yes, that's all. I think that we don't have much time, and so this is my presentations, and please have a questions, and or you can look those products, or if time permits, I show you some demonstrations. Yes. Yeah. Yes. Soリアルはよいしょ。This is a token. I have to say that I am also an official Debian developer, and I put my own key, GPG key, into this one, as well as I put my SSH authentication key here. Yes. So I put my token here. It's a version 1.0.1 of FSIJ USB token. Yes. This is the USB ID of our organization, FSIJ. The agreement is like this. The USB, I assign my all copyright to FSIJ. In return, I got the second source manufacturing license such that I can manufacture this token. Yes. Now I examine the card status. Oh, sorry that it's in Japanese, but you can read the Chinese characters. This is the status. This is a public key URL, my login name, and this is a fingerprint of the card, a fingerprint of my key, signature key, encryption key, and authentication key. Yes. This is the ID, application ID of this token. Yes. And well, let's let's sign, make sign. Yes, it asks my pin. It's long enough. And let's see, 1 point second. Yes, it's enough for me. Yes. And yes, we have a good signature. Or another example would be SSH to my host. One point second, but I think that it takes some time to resolve the name, or SSH is, okay. Now, it takes time to resolve the name, DNS. Now I enter my passphrase to enable access of authentication facility, and it takes 1.5 seconds to get a prompt. You see, for me it is enough. Yes, and once I enabled the access to this token, the second time I don't need enter passphrase anymore. But it takes time to resolve. In fact, it's not the time of the cryptographic calculation, but DNS resolve. It's in Japan. Yes. Yes.
Does it still need to be plugged in?
Yes. Yes. You cannot to be authenticated. Yes. Yes. So this is the real use of the token. It's just we need a configuration, but once done, it's just using GnuPG or OpenSSH. Yes. That's the demonstration. And let's see my schematics. Yes. See, this is a schematic. Here we have a controller, and this is a regulator. This is a USB terminator. Yes, that's all under crystal. Crystal is there. Oh, sorry. Here, crystal. And this is a bomb. And yes, this is the PCB design CAD. This is the front side. And this is backside. Yes. This is a KiCad environment where I develop my hardware. And the source code and the design is available at my repository at Gitorials. How come? It's slow. Yeah, here I put all the repository here. Gnuk implementation, noisy, which is the true random number implementations, and the binaries is available too, and the documentation in Japanese is also available. The kernel and this hardware design is here. Yes. So that's my presentation and the demonstration. Do you have any questions or comments? Or how about how is your impression, or do you have an idea to use such a token in future? Or my point is that please consider your security when you are using the encryption or authentication or digital signature. Then unfortunately, some government is our enemy, perhaps. So you need care about your own privacy. That's my point. And free hardware design matters a lot. Yes, that's my point. Thank you. Thank you very much.